Hey guys, today we're going to talk about the golden ratio, commonly denoted as phi, and for you guys we have 4 ways to determine the value of phi. For our first one, we're going to talk about the definition, which is a positive number such that adding 1 to itself obtains its square. Rearranging the terms on the right to the left, we get a quadratic, which we can solve with the quadratic formula. Plugging in the values of a, b, and c, we get x is equal to 1 plus or minus root 5 all over 2. Since we talk about a positive number, we have to eliminate the negative root, and we're left with phi is equal to 1 plus root 5 all over 2. For our second example, we want the small rectangle on the right to be similar to the large rectangle encompassing everything. For this to work out, we want the ratio of the small sides, 1 over x, to be equal to the ratio between the large sides, x over x plus 1. Cross multiplying, we get the same equation we had in example 1, and then solving for the quadratic again, we get phi is equal to 1 plus root 5 all over 2. Phi can also be derived from the Fibonacci sequence. Specifically, phi is equal to the limit as n approaches infinity of a sub n over the previous term. So 1 over 1, 2 over 1, 3 over 2, 5 over 3, 8 over 5, and so on, eventually approaches phi. Now remember, the nth term of the Fibonacci sequence is the sum of the two previous terms. We can use this to rewrite our original limit as a sub n minus 1 plus a sub n minus 2 all over a sub n minus 1. We can break this fraction up, and now the left-hand side of this expression simplifies to 1. And if we let x equal to our original expression, we see that the expression on the right is equal to 1 over x, since a sub n minus 2 over a sub n minus 1 is essentially a sub n minus 1 over a sub n. Condensing everything together, we get x is equal to 1 plus 1 over x. Multiplying both sides by x, we get x squared is equal to x plus 1. And solving for the quadratic again, we get x is equal to 1 plus root 5 all over 2, which is phi. Phi can also be derived from the diagonal of regular pentagon with side lengths 1. If we let the diagonal equal x, we can extract this triangle. And since we know that the angle of the interior angles of a regular pentagon are 108 degrees, we can draw the perpendicular bisector of the diagonal, and this 108 degrees becomes 54 degrees. And since we have a right triangle, we can find sine of 54 by taking the opposite over the hypotenuse. Sine 54 just happens to be 1 plus root 5 all over 4, so we can solve for x, and we get phi again, which is 1 plus root 5 all over 2. Now, finally, combining these definitions together yields this really interesting spiral, which is commonly seen in nature and is used in many famous works of art. Thank you for watching. Hopefully you learned something new today.